Page 4 of lines. So number 5 says, line MN is parallel to the y-axis. And the coordinates of M and N are M, which is an unknown value, comma 24, and negative 5, comma 2. Write down the value of M. Okay? So I'm going to try to graph some of these points here. So I'm going to put x-axis here, y-axis here. I'm going to count by 5s because 24 is a really big number, right? So negative 5, negative 10, 5, 10, 20, 30, 10, negative 10. Okay? Then I'm going to mark my points in blue. So negative 5, 2 would be about there, right? And something, comma 24 would be somewhere to the left or somewhere to the right. We don't know because the M is unknown, but it's at height 24. So it could be like here, could be here, could be here, could be here, could be here, right? As long as the second coordinate is 24, I know it's somewhere along. Hey, it looks like it traces out a line, doesn't it? It traces out a line right there, doesn't it? So I could, using the drawing, already see that the y coordinate should be negative 5. So M should be negative 5, right? Another way to do it is, since we know that MN, which is the line which connects the 2 points, is parallel to the y-axis, in our drawing, we would see that if it goes through negative 5, 2, and it is parallel to the y-axis, we can see that it's a vertical line. And the vertical line, when it goes through this yellow highlighted line, you can see that it's going to go through the point negative 5, comma 24. You could also say, okay, if it's parallel to the y-axis, that means it's a vertical line. If it's a vertical line, then that means that all x coordinates on the line are the same. And we see that the x coordinate of one of the points is negative 5, comma 2. Every other point on the line has to be negative 5 something. So we have negative 5, comma 2 here. This point here, for example, would be negative 5, comma 15. And this point here would be negative 5, comma 20. Or negative 20. So all the points on the blue line are negative 5, comma something. So that means that M also needs to be negative 5. Right? Okay. The gradient of a second perpendicular line is the negative reciprocal of the gradient of the first line. Remember that from the investigation? So let's see what they're going to ask us. 3D. Which of these pairs of numbers are negative reciprocals? Okay, so let's see. If we take the first number 2 and we take the inverse of it, the reciprocal, and then we take a negative, does it equal that? Yes. So they are negative reciprocals. What about negative 4/3 and 3/4? If we invert 4/3, it becomes 3/4, and if we take the negative of it, it'll be plus 3/4. Is that the same? Yes, they are negative reciprocals. What about 3 and 1/3? If we take the reciprocal of 3, we get 1/3, and then if we take the negative of it, it's negative 1/3. Is that the same? No. What about negative 1 and 1? This one's a little bit tricky. So if I take negative 1 and if I take 1 and I invert it, I get 1 over 1. And then I take the negative of it to take the negative reciprocal. Then I'm sorry. So if I take the negative of this, it's going to be positive, right? So positive 1 over 1. And I check to see if it's the same. It is the same. Okay? Another way you could do it is you could multiply each of these together. If they're negative reciprocals, if you multiply them together, you should get 1. So if I multiply together 2 and negative 1/2, the 2's cancel, I get negative 1. So it worked. If I multiply 3 and 1/3, I end up with 1. I don't end up with -1, I end up with 1. To find out if they're negative reciprocals, I need to multiply them together and get -1, not 1. So that's another check you could do. Which of these pairs of gradients are of perpendicular lines? Okay, perpendicular lines have gradients which are negative reciprocals. So if we see that they're negative reciprocals, if we, for example, multiply the two together and get -1, then we know we're fine. So this gives us 10 over 10, which is equal to 1. Is that -1? No. So it's not, they're not perpendicular lines. What about 4/3 and -3/4? If we multiply these together, we get -12 over 12, which is -1. Is that is that a sign that it's they're perpendicular, or that the gradients are negative reciprocals? Yes. What about -3 and 1/3? So -3 and -1/3. If we multiply those together, we get +3 over 3, which is +1. So no. And last of all, if we multiply together 1 and -1, we get -1. So yes. All right. All right. Next, find the gradient of lines that are perpendicular to a line with gradient. So we're going to find a gradient which is perpendicular to this gradient. So -3, we would take the reciprocal of it, and then we would take the negative of it. So that would be equal to +1/3. So that's the answer for A. For B, I'm going to take 2/3, and I'm going to take the reciprocal of it, which would be 3/2, and then I'm going to take the negative of 3/2. So that would be the negative reciprocal. And -1/4, I would take the reciprocal of it, and I would and then I would take the negative of negative, so it would be +4. And I can check my answer by taking the answer I get and I multiply it times the original gradient, and I should get -1, and I do. So that's a way to check to see that you're getting the right negative reciprocal gradient. What's the reciprocal of 1? It's just 1, and I take the negative of that to find the negative reciprocal. What is the reciprocal of -1? It's -1 over 1. And I take the reciprocal of that, it's +1. Okay, number 4. Find the gradient of any line perpendicular to the line passing through the points -2, 6, and 1, -1, and 5, 10, and 0, -2. Okay, so I'm going to use the calculator method to find the gradient between these points. So I'm going to turn on the calculator. And then I'm going to go to stat. I'm going to do linreg, okay? Just to get you used to doing that. I'm going to put -2, 6. Our next unit is linear regression. Then you're going to do this for real. 1, -1. Okay, so I just put the two coordinate pairs, -2, 6, and 1, -1 into L1 and L2, and you see it goes across when I put them in. And then I'm going to do stat calc linreg, which is number 4. And L1 and L2 are automatically there, so as long as you used L1 and L2, you don't need to do anything there. And then you go down to calculate. And then our slope turns out to be -2.33. It's our A value. Y equals AX plus B. Remember, Y equals MX plus C. So the M is the slope. A is the slope here. So my slope turns out to be -2.33. And if I would like to find the gradient that is perpendicular to that gradient, I would find the negative reciprocal of that, -1 over M. So it would be -1 over -2.33. So that would be +1 over 2.33. Let's use our calculator to find that. 1 divided by 2.333333. What's that equal to? It's 0.428. 429, right? If I'm going to do three significant figures like we should do in math applications, I should round the 8 to a 9 because the fourth significant figure, 5, rounds the 8 up, okay? All right, now let's do between 5, 10 and 0 and -2. And you could do it with algebra if you want to, but you already know how to do that, so I'm just going to show you how to do it with the calculator again. So we're going to put 5, 10, and we're going to put 0, -2. So 5, 10, and 0, -2. And, yep. And then we're going to do stat calc ln reg, which is number 4. Let's see what the slope is. So the slope happens to be a equals 2.4. So the slope is 2.4. And what would be the gradient of the perpendicular to that slope? So then we just go to the regular screen and we do -1 divided by 2.4. And we get -0.41666, which I'm going to round to -0.417. So if you would like to make that equal to a variable, you could say it's equal to m dash, because m dash is often used to represent the perpendicular to a slope. Okay, another way you could write it is you could write m perpendicular. Doesn't that look like a perpendicular sign? Okay, it's like an upside down capital T. All right, moving on. Number 5. Each diagram shows a line and a point A. Write down the gradient of the line. Write down the gradient of any line that is perpendicular to this line. Copy the diagram. You don't have to copy the diagram, it's right there. And draw a line perpendicular to the red line passing through point A. Okay, so the gradient of this line we could find counting blocks, or we could do ln reg. How would you do it with ln reg? I would say, okay, it goes through 0, 0, and it goes through -1, 3. So I would put 0, 0 and -1, 3 into stat edit, and then I would do ln reg to see what the slope is. But this is a pretty easy one to see by counting blocks, so I'm going to count blocks. I see 3 horizontal blocks, and I see I see 3 vertical blocks, and I see 1 horizontal block. Rise over run, so 3 over 1. Is it negative slope or positive slope? It's negative slope because it's going down, right? So I'm going to put -3. So my slope of this line here is -3, and my my perpendicular slope to this would be -1 over -3, which is equal to 1/3. So the slope of the perpendicular would be 1/3, or the gradient of the perpendicular. And then I'm going to draw a line which goes through point A, which is perpendicular to the slope. So it would look about like that. Okay? And do you see how like it just so happens that this triangle is also a triangle that has one side 3 and one side 1, just like we saw in the investigation. It's a similar triangle to the red triangle. It's just on its side. Okay? All right, let's do the next one. So now we're going to do this one that also it looks like we could count blocks pretty easily. So why don't we do that? So horizontally, I see that we have 4 blocks. And vertically, I see that we have 2 blocks. We could have done it with 2 and 1 also, I think. So our slope is 1/2, right? And is it a positive 1/2 or negative 1/2? Well, the slope is going up, so it's positive, right? Then I'm going to find the perpendicular. The perpendicular would be -1 over 1/2. And that, we can use a calculator to do that if we want to. So it would be -1 divided by, and let's do this instead. I'm going to show you how, like, this gets confusing, right? Even for the kids in Math SL, they often ask me this question. If I have a fraction over fraction, what do I do? The important thing is to put parentheses over things that are like the fractions you input into the thing. So let's do the math number. We go right, and then we go one up, and that takes us to the last item on the list, which is n/d. n/d is nice because we can rearrange it into a fraction in a fraction. So I'm going to put -1 divided by, and in the bottom I'm going to put 1/2. I could put 0.5, which makes it a little bit easier to understand, or I'm going to put parentheses 1 divided by 2. And actually, I don't even need parentheses here because, remember, this is like a vertical fraction doesn't require you to put parentheses. So I could just put 1 divided by 2. And the parentheses are understood. You know, the top parentheses and the bottom parentheses are understood because this is a vertical fraction. Okay, and now I'm going to press enter. And it tells me that it's actually -2. And that makes sense, right? Because if I inverted 1/2, I would get 2 over 1, right? So, and then if I took the negative of it, it would be -2. And now I'm going to draw a line which connects point A with the red line at a at a perpendicular slope. And I'm going to use this slope of -2 to draw the line. So -2 means the rise is -2 and the run is +1, for example. So rise of -2 and run of +1 would be like that, right? Because like if I drew this triangle, it would be horizontally I'm going +1, vertically I'm going -1. Okay? So that's how you would make sure that you drew it exactly right, by using the slope that you calculated. C. So on this one, first I'm going to find the slope of the red line. And this one, let's see, oh, here. If I go from here to here, then those look like good points because they're exactly on the line. I can count the blocks, right? So I got 4 for the vertical distance, and I got 3 for the horizontal distance by counting the blocks. And is it a positive or negative slope? It's going up, so it's a positive slope. So our m value is 4/3. And what is our perpendicular slope? Our perpendicular slope, our perpendicular gradient, we would invert the 4 and the 3. We would get 3/4, and we take the negative of it. So that would be our perpendicular slope. So that means that when we draw the perpendicular that goes through point A, we are going to have a rise of -3, and we're going to have a run of 4. So let's see, rise of -3. So we would go down 3, and then we would go over 4. So it would be kind of like that. And so if we were working backwards, we'd count back 4, and we would go up 3. Okay, so that's kind of what it would look like. All right. Okay, and so that blue line should be perpendicular to the red line because we drew it with a slope of -3/4. And I think that's it for this page.